Hello and welcome back. So we are going to be starting our lecture today on a new topic called function transformations. This is one of my favorite sections. You're going to get a lot of use out of this one, I hope. So before we get to that though, let's knock out the homework that we had from the composite functions. So we had to start with, for number one, we had f of x is equal to 2x plus 7, and then g of x was equal to x squared. Okay, so it asked for f of g of x. So I know I'm going to take whatever my g of x is, this value right here, and I'm going to substitute that in for every x that's in my f of x. So with that in mind, I'm going to get f of g of x is going to be 2 times, it's going to be x squared plus 7. I just replaced that x with the x squared of g of x. Alrighty. And then I had g of f of x and g of f of x. Well, now I'm going to take f of x and substitute it in for the x that's in the g of x function. So I'm going to get, instead of x squared, I'm going to wind up with 2x plus 7 squared, like that. That makes sense? I sure hope so. All right. So let's tackle the second problem now. We had f of x is equal to x cubed minus 3x plus 5. And then g of x is equal to x plus 7. And then we're supposed to find f of g of x. Okay? So I'm going to take my g of x function and substitute it into my f of x wherever there's an x. So I'm going to wind up with x plus 7 cubed minus 3 times x plus 7 plus 5, just like that. Okay? Alrighty, so let me clear this and we will start in on the next one, the final homework problem. So clear that. And for the third one, we had a bunch of stuff. We had f of x is equal to 5x squared plus 2x, and then g of x was equal to x plus 3, and then h of x was equal to root x, and finally j of x was equal to 4x plus 1. Okay, so what is f of g? Actually, let me shift that down to one where it'll line up a little bit better. So erase, 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 erase. All right. What is f of g of x? Well, f of g of x is going to take the g of x function and substitute it in wherever there's an x in my f function. So this becomes 5 times x plus 3 squared plus 2 times x plus 3, just like that. Okay, and you can see the end result has the g of x, x plus 3 untouched. So that's why I know that I did it right. The g of x is the interior function of my composite function, and it appears untouched over in my answer. All right. So next we wanted f of h of x. And so f of h of x is equal to, well, I'm now going to take the h of x and substitute in wherever there's an x. So this is going to be 5 times root x squared plus 2 times root x. That's it. That's all you have to do. You don't have to simplify it. Well, not finally, but for this little kind of excursion, f of j of x would equal what? Well, I'm going to take this 4x plus 1 and substitute it in for every x. So I'm going to get 5 times 4x plus 1 plus 2 times 4x plus 1. It's supposed to be a 1 there. Alrighty. So not bad. But now here's the question. What is f of x? This one's a little tricky because what I'm going to wind up doing is taking the entire f of x function, f5x squared plus 2x, and substituting it in for each of the x's. So this is going to be, here we go, 5 times 5x squared plus 2x quantity squared plus 2 times 5x squared plus 2x. And if you look at the previous three compared to this one, it follows exactly the same pattern. What am I substituting in for this interior piece that's untouched? Well, in this case, I'm substituting in f of x. So I just fill in 5x squared plus 2x, which is the entire function. And that's it. That's all there is to it. So if you're good with that, let us move on to the beginning of function transformations. All right, so let's clear this and start in on that. Okay, so we're going to be doing function transformations. That is a very big title to something that is at its heart not all that complicated, which is good. Most students really enjoy this part. It's a nice break from composite functions if they're driving you crazy. So what are function transformations? Well, let's say that we start off with a function like f of x equals x squared. Okay? So what does that look like? Well, that is our standard parabola. That opens up something like that, right? And it's peak down here, so it's valley, I guess I should say, since it's a reverse peak, is located at 0, 0. And that makes sense because if I plug a 0 in for my x, what do I get for my y? And remember that f of x, it's kind of synonymous with y. Well, if I plug a 0 for x, I get a 0 for y, so that's why it's at 0, 0. So that location is right there. Now, function transformations, there are two types, okay? So I can spell, I promise, two types of function transformations, okay? Burn this one in. There are vertical transformations, and you guessed it, horizontal, okay? Now, we're going to start with vertical transformations, and then we'll move over into horizontal transformations. And we'll also be using Desmos a little bit to be able to actually see what's going on. So first thing, let's start off with what do I mean by vertical transformations and horizontal transformations? Well, if I take my function and I want to do something to it, oops, didn't mean to make that little stray mark, erase. If I take my function and I want to shift the function vertically, or maybe stretch or shrink it vertically, or reflect it, all sorts of things, that's a vertical transformation. If I want to then shift it left or right, or stretch it left or right, or things like that, that's going to be a horizontal transformation. So if I do things to the function that changes it up and down, that's a vertical transformation. If I change it left and right, it's a horizontal transformation, okay? So let me give you an example of what I'm talking about. So let me clear this, and we're going to start in with our good friend f of x equals x squared. So f of x equals x squared, just like we had it. It looks something like this, assuming I can draw, and it's got its very lowest point at 0, 0. Okay? what do you think f of x equals x squared plus 1 is going to look like? Well, what's going on here? If I plug a value in for my x, I'm going to add 1 to it, and that's what the y value gets. Okay, because again, this f of x, this is basically y right here. So if I have x squared plus 1, I'm actually going to have exactly the same graph, except it is going to be shifted up by 1. So now this lowest point, assuming I can draw, is located at 0, 1. So if I take a function and want to shift it up, I'm going to add to that function. If I want to shift it down, I'm going to subtract from the function. And that is a vertical transformation because it is changing things up and down. Transformation. Okay? So, let me give you some examples. Let's go over to Desmos and you can see exactly how this works. So, here we go. Let me clear this. Clear this. Apparently I'm unable to clear things. There we go. And now let's head over to Desmos. Okay, let's see. We are here in Desmos. And first let me graph y equals x squared. Okay, so there we have our parabola opening up at 0, 0 down here. And if I want to shift it up, I just add the amount I want to shift it by to the function. So y equals x squared plus 1 just shifts it up by 1. If I want to shift it down by 1, I would do y equals, let me close this first now, y equals x squared minus 1. And now it shifts it down. So shifting a graph vertically, if I want to shift it up, I add to the function. If I want to shift it down, I subtract from the function. And that's all there is to it. And this works for any function, no matter how complicated the function looks. I could start off with something maybe that's a little more complicated than this. Y equals 3x cubed minus 2x. Okay, so there's my function right there. If I want to shift it up by 1, all I do is I take that function. I'm just going to put it in parentheses to really show what's going on. That's 2x plus 1. And it shifts it up by 1. Every point on the original graph is now shifted up by 1. Every single one of them. Okay? So let me go back to the drawing area and we'll talk about this in detail a little bit. So heading back there. Let's see. Okay, so let's say I have f of x equals 3x to the fourth minus 2x plus 7. And I want to shift up by 5. How do I do that? Well, all I have to do is take this function, I'll put it in parentheses so it's really, really clear, and then just add 5 to it. Which if I wanted to, I could add the 7 and the 5 to get 12, but this is even more clear what's going on. I'm adding 5 to the entire function to shift the function up by 5. Okay? Now, let's say instead, if I wanted to take this same function, so 3x to the fourth minus 2x plus 7, and I want to shift it down by 13. How would I do that? Well, that would be the entire function as is, untouched. I like to put it in parentheses to really isolate and show what's going on. So that's my original function. If I want to shift it down by 13, I subtract 13. And that's it. That will shift it down by 13. So this is our first vertical transformation. Vertical transformation. Transformation. That's a lot of writing. I may have to abbreviate this. Okay. So it's going to be to shift up, add, to shift down, down, subtract. What am I adding or subtracting to? I'm adding and subtracting to the original function. To the original function. Okay? So, let's do another example. Clear this. So if I have maybe f of x is equal to the 7th root of x to the 4th minus 3, or rather plus 3x. Okay? If I want to shift, this is going to be my original function. Original. If I want to shift f of x up by 9, what do? Well, I take the function, the original function, I put it in parentheses, 7th root of x to the 4th plus 3x, and just add 9. If I want to shift f of x down by, I don't know, pi, I take the original function in parentheses to really emphasize, x to the 4 plus 3x, 7th root of that, and then I subtract pi. That's it. That is your very first transformation. That is a vertical transformation. And now here we go. I want to write this out. Vertical transformations always apply to the whole function, the entire function, the original function. Okay? And I'm going to put a little thing in parentheses right here. They make sense. You'll see why in just a second, why I'm putting this in here. Okay? If I want to shift a function up, I take the whole function, put it in parentheses, and add whatever the shift is. If I want to shift it down, I take the whole function, put it in parentheses, and subtract that shift. That's all there is to it. Okay? That's already a lot of power, but let's add to that power. All right? Next thing we're going to do is a horizontal shift. So let me clear this, and we'll do a horizontal shift set now. So clear that. Okay, so now we're going to do, wow, what was that? Okay, clear the screen again. I don't even know what that was. I liked it though. So now we're going to do a horizontal transformation. Transformation. Okay, and we're going to stick with a shift, but now we're going to be doing shifting left and right. Okay, so there's a left to right shift. That makes it a horizontal transformation. So how do you do that? Well, for a horizontal transformation, let's say I want to shift left. So on my base function, that my original function I want to start with. Let's start with our good friend x squared. If I want to shift left, here we go. I'm going to replace every x value in the base function. And let me shift left. I'm going to put a little number here so I can use it as an example. By 7, okay? Replace every x value in the base function with x. If I want to shift it left, which is towards the negative side, I'm going to add 7 to it. Okay, I'm going to replace every x in the base function with x plus 7. Okay, so this one would become, instead of x squared, x plus 7 squared. Okay, this will shift the normal parabola of x squared to the left by 7. Okay, notice if I shift it left, I add. Can you guess what I do if I want to shift right? Let's say I want to shift right by, oh, I don't know. I have no idea. 7. I've already done 7. Let's do, I'm running out of numbers in my head. I feel like I've used them all. By 8. Alrighty. What do? Well, I replace or substitute, whichever you prefer. I'll probably say both over time. Replace every x value in the base function with x minus 8. So if I want to shift it right, which is in this direction, it is a minus sign right here. So what is that going to look like? Instead of x squared, it's going to be x minus 8 squared. And that is going to shift it right by 8. Okay? So, two things about horizontal transformations. All right, let me clear this. So we're all horizontal transformations. Horizontal transformations. Here we go. Number 1 observation. They apply to every x value. And I like to just avoid any kind of ambiguity and just say replace every x value. Okay? 2, they are the opposite of what you would expect. So, what do I mean by that? Well, if I want to shift, let's say my base function is, I don't know, 5x cubed. And I want to shift it right by 4. I'm going to replace every x with, if I want to shift it right towards the positive side, I subtract the shift, x minus 4 cubed. That is the opposite what I would expect. If I'm sending it to the right, to the more positive values, you would think that you would add 4 here, but you don't. You subtract 4. It is all horizontal transformations are going to be the opposite of what you might think. If I'm shifting it left by 11, I replace every x by x plus 11 cubed. So instead of the x value here, I'm going to replace it, if I want to shift it right, by x minus 4. If I want to shift it left by 11, x plus 11. Okay? One of my cats is trying to get in on the act, so hi Moxie. Alrighty, kitty cat. You might pick up her purr in the microphone. Sorry about that. Alright, she's insistent that I give her some love, so oh well. I wish you could see her. She's beautiful. So, this is very strange. The vertical transformations make perfect sense. Okay? Vertical transformations apply to the whole function, the entire function. We just put it in parentheses. And then if we want to go up, we add. If we want to go down, we subtract. Horizontal transformations don't apply to the whole function. They apply to every x value. And how do we apply them? We replace every x value with the transformation. And they are always in the opposite sign of what we would expect, or the opposite operation, I should say. And if I want to go right, I subtract. If I want to go left, I add. That's it in a nutshell. So let's look at some examples inside of Desmos again. So let me clear this, and then we will head to Desmos. So clear that, and here we go. Okay, so here we are in Desmos. Let's start off with our base function again of x squared. Now, if I want to shift, let me do y equals so I don't get into a little bit of trouble with that. So y equals. So how does this change if I want to shift it to the right by 3? Well, if I want to shift it right, I know I'm going to subtract, which is the opposite of what I would think I would do. And I'm replacing every x with x minus 3. So if I want to shift it right by 3, I want to replace the x's with x minus 3. And square that. And what do you know? What was over here is now shifted over to the right by 3. Okay? If I want to shift it left by 2? Well, if I want to shift it left by 2, I do y equals shifting it left, so I'm going to add to the x, so x plus 2, quantity squared. And now it's shifted left. Okay? That is it in a nutshell. If you got that down solidly, there's nothing you can't do. And again, this works for any function. But because you are replacing every x, you have to make sure that you replace every x with a transformation. So if I had y equals x cubed plus minus 2x squared, something like that. If I want to shift it right by 3, I am going to change every x into x minus 3 minus 2 times x minus 3. What do you know? The original function is now shifted right by 3. Okay? That's how it works. I will now head back to the blackboard and do a few more examples of this. All right, so here we go. Okay, so let's do a function. Let's do f of x is equal to 7x cubed minus 5x plus 1. Okay? Let's say that I want to shift up by 13. How would I do that? Well, I take since it is shifting up, it is a vertical transformation. So the transformation is going to apply to the entire function. So I just take the whole function, put it in parentheses, 7x cubed minus 5x plus 1, and then I do the transformation. I'm shifting up, so I'm going to add 13 to the entire function. Okay? Now what if I wanted to shift right by 4? What would I do? If I want to shift right by 4, now since it is a horizontal transformation, it's shifting to the right, I have to take every x in my original function and replace it by what? I replace every x with, if I'm shifting right, I'm going to subtract 4. So this function becomes 7 times x minus 4 quantity cubed minus 5 times x minus 4 plus 1. That would shift the function, the original function, right by 4 because now every single x has been replaced with x minus 4. That makes sense? Alrighty. So what if I wanted to shift down by, let's go with 19. All I have to do is take the original function. It's a vertical transformation, so I take the whole function, put it in parentheses, and then if I'm shifting down, I'm going to subtract that 19. Okay? Now, what if I want to shift left by, I don't know, how about 1? Shift left by 1. Well, I'm going to replace every x in the original function, every x, with what? Well, if I'm shifting left, I know that it's the opposite of what I expect since it's a horizontal transformation. So I'm going to replace every x with x plus 1, right? So here we go. I'm going to have 7 times x plus 1 quantity cubed minus 5 times x plus 1. Okay? So there you go. That's how you handle function transformations. If it is a vertical one, not the very first part of function transformations, we've got lots more to go, but for right now, this is pretty good. So if it is a vertical transformation, in other words, shifting up or down, you take the whole function, put it in parentheses. If you're shifting it up by a factor, you add that factor. If you're shifting down by a factor, you subtract that factor. Perfect common sense, super easy. But if it is a horizontal transformation, instead of applying to the whole function, you wind up replacing every x in the original function with your transformed x. If I want to shift right by a factor, I subtract that factor from x. And that's what I substitute in for every x. If I want to shift left by a factor, I need to add that factor to what I'm going to substitute in for every x. I know it's crazy, but that is the way it works. And there's a good reason for it. It's just not satisfying to very many people. I used to spend a good chunk of time going over the justification for all this mathematically, but I've found out over time that not many people really cared about that justification. So if you want to see it, swing by one of the office hours someday and ask that question. I'm happy to show it to you. All right, so we're going to clear the screen and we're going to go to the next one, and I'm going to write everything down and then give you some homework to practice with this, okay? So clear the screen. Here we go. Vertical transformations. Okay, now vertical transformations, what we're doing right now are up and down. We'll be doing some others in the next lecture, but right now it's up and down. What does that mean? Well, I apply the transformation to the entire function. And what I recommend is just putting the whole function in parentheses, and then if it's up, you add, if it's down, you subtract. Also, the transformation makes sense. It's what you would expect. Up, add, down, subtract. Okay? Horizontal transformations. And these are the ones most people don't like. Okay? And for right now, all we have are left and right. Okay? So, in this case, you replace every x with the transform x. Okay? And we saw that if I want to go right, I'm going to subtract from the x. If I want to go left, I want to add every x. And I can even put that after this next step because this is under here. It is the transformation is the exact opposite of what you would expect. Of expectation. Okay? In other words, if I want to go right by a factor, I'm going to replace every x with, if I'm going right, I'm going to subtract the factor. Okay? When we go left by a factor, some amount, I'm going to replace every x with x plus the factor. So, make that a little bit neater. The transformations, if they're horizontal, are always the opposite. If I want to go right, I subtract from the x. If I want to go left, I want to add to the x. And I replace every x in my original function with that altered one. Okay? So, let's talk about homework now that we've kind of wrapped all this up. So, clear the screen. If I can figure out, there we go. Alrighty, so, homework. I'm going to give you the base function, and then you do the transformation. So the base function, this is going to be number 1. Base function is going to be x squared. Okay. For part A, go right by 3. Okay. Part B, go down by 7. Okay. Number 2, the base function is going to be, let's say, x cubed plus 2x. Okay. Part A, go left by 5. Part B, go up by 13. Last but not least, number 3. Here we go. The base function is going to be 7x to the 4th plus 3x plus 5. A, go over to the right by 10. B, go down by 10. Okay? See if you can figure out how all that works. Go back, look at the examples, and if you want to check your answers, just go to Desmos and type in what you think it would be and see if it actually does what it's supposed to do. And remember, if it is a horizontal transformation, here, here, and here, you replace every x with that transformation. If it is a vertical one, here, here, and here, you take the whole function, put in parentheses, and then apply that transformation. That's it. Good luck, and I will see you next video. Take care, y'all, and stay safe.